We chose to build our robot out of acrylic due to the strength and that we can see through it so that we can see the functionality of the inner workings. One thing that we ran into is that the acrylic is a 1/4 inch thick all around and is very heavy, and so our wheels, our stepper motors, didn't have enough torque to output it. So one thing we would change is that instead of using 1/4 inch for everything, we would use 1/4 inch on the base and 1/8 inch on everything else.
The design of the base plate was such that it would allow for ball casters to be placed that helped steady the robot and help support the weight, but it was also designed to get into the corner. What we would do differently is we would increase the corner edges, and so basically it would be, the corners would be this instead of the current design, and we'd put the motors on the side to help with that, and that would allow us to get into the corners much more easily.
So one other great design feature that we had was actually a little fan on the back to trip the laser. Now, this was attached to a DC motor and spun very fast, and this actually worked out really well for our design because the quickness of the fan triggered balls to come out really fast, and with our sorting mechanism, it was able to sort balls fast, so it was perfect to get the maximum number of balls in the shortest amount of time.
With our sorting mechanism, we set up our phototransistor on the end of the servo arm so that as the balls touch it, it senses if it's white or black and pushes the white ones over to the white magazine. To do that, we had to angle our whole top area so that all the balls would be forced to roll past that phototransistor. For the storage of our balls, we decided to go with a magazine style. We have the magazine set up so that balls will roll down, and as they go down, they hit these little paper arms we created to kind of keep them from stacking up on top of each other. We used a laser cutter to cut the acrylic so that every piece was precise and so that we could, for the most part, press fit them all together. We chose magazines because they're very space efficient. One impossible design change we would implement is putting nice 3D printed ends so that the balls would never get stuck.
Now with our magazines, we needed a way that we can control which balls go down to the shooter at what time. So the way we did this is we put 2 servos right here with some plates of acrylic to hold the balls in. Kind of the way our code worked is that our pick would get a signal from an IR sensor in the front telling it whether it was a white or a black goal, and then it would send a digital signal over to an Arduino, and that would then open up one of these servos just like this and allow all the balls to roll down to the shooter. The reason we used an Arduino is because we had a lot of trouble using the multiple PWMs on a pick, and so if we had more time, we probably would have gone back and figured out how to use multiple PWMs on a pick.
So for our scoring system, we decided to choose to do a shooter. We simply began with a 3D printed barrel, as you can see here, and we adjusted it to a movable base plate. And then we also configured some ramps made out of acrylic and PVC pipe to be able to bring the balls from our magazines and send them down to our shooter and launch them with 2 DC motors. So one design change that we would implement to improve our shooter would be to give it an adjustable mounting system so that our shooter can be calibrated more precisely just with the unscrewing and screwing of a single bolt.
So this is the main circuit platform for our robot. This came about because what we did is we sat down and we mapped out all of the electrical components. We put all the circuits down, we mapped them together, we simplified, redefined, redesigned until we basically came up with the most simple thing possible. We did that so that we could have all the electrical components all together, all without the outside of the mechanical system. The way that we executed that is that we laid them all out in our design, the way that we had designed, and we soldered all the connections together and tested each connection so that we knew that they would be great. And then we heat wrapped them as well. All the connections here are beautiful, wonderful. It all works together perfectly.
So with our code, we started out with block code, but we found that it would be a lot easier when we implemented the states. So we changed that out completely and redid our code from scratch. Another thing that we did when coding was that we made sure to comment just about every single line so any member of our group could edit the code easily. And if we could give our code to somebody else and they would be able to understand it and use it as well.
So overall, even though our robot didn't perform as well as we would have liked in the competition, we would really keep the same overall design. We loved having the challenge of sorting, we loved the magazine design and the shooting design. I feel like it was really ingenious. Another great thing was that each of our team members contributed on all the different parts. All of us got experience doing coding, all of us got experience with circuitry, and all of us did some of the hardware and prototyping. Overall, we really did learn a lot of mechatronics. And yep, peace.